By data-driven, I mean every feature we implement, we're always thinking about A/B tests, experiments, running through analysis to understand what is the best for the traveler. By the traveler, we mean the final user. So thinking about a data-driven environment, I think that a lot changed really quickly. So how do we create a flexible code base that we can experiment without too much compromises? Mobile development on its own has a lot of challenges. For example, we know offline support, battery optimization, data consumption, performance, memory management, and many others. And on top of that, we also have release cycles problems. Again, Skyscanner is an example. We have fortnightly releases for each platform. So if you merge your code to the trunk at the day of the code freeze, you would have to wait 2 more weeks until it starts to be in a release candidate, and then more 1 week if everything goes well during our phased rollout. So it can be up to 3 weeks that would wait for your code to be merged until it's being released. But it doesn't mean it's adopted by the majority of the users, because we have an average of 8 weeks of a version to being the majority in the hands of the user. So if you think about a feature that is a breaking version or something like this, you really need to think through it, because unless it's Sony, it stopped working here. Backwards compatibility is a must-have. And it is a problem not only on mobile, but especially on mobile because of the release cycles we talked before. So, can you hear me? I think it got, okay. So this talk is about an architecture proposal that started as a refactor of a legacy code and ended up as a foundation of a scalable and trustworthy framework that remotely builds a feature called unified search on one of the biggest travel apps in the global market. So we go from situation, talk about recognition of problems, creating a strategy, committing to it, rollout plan, further iterations, and then finally the learnings, if you had some. Okay, so no further delays. We start with the situation. If you have ever used Skyscanner app before, this is a app that helps you to research, plan, and book your trips. But our main focus so far has been, this is early 2019, that's the context, the background. Our main focus were flights, we call it Skyscanner, right? So if you used the flight results before, that is a really important feature to have in our app. And it has about 7% of traffic of the entire app. It also counts a lot of the revenue comes from this. It's in production for about 7 years. To be honest, I think it's more, but I couldn't find it exactly. But you can think about 7 years. The current status of it, my team was responsible for this. We'd have the ownership. But the current responsibility of it was pretty much maintenance. We're trying to fix stuff coming from production issues and also a lot of code reviews on other squads' contributions. It's okay. So it's a really important screen, so you can think many other teams trying to experiment features inside of it. So another good thing to talk about, the overall knowledge of the squad in the terms of the code base was very low, especially because the most experienced engineers on that legacy code have rotated to other squads. So I think the most legacy experienced engineers I had there had about 6 months of company, so not the best state. So talking about legacy code, I think it's important so we can have a common ground of what it means. So legacy code is source code inherited from someone else or inherited from an older version. At the end of the day, it's something that you don't understand or it's difficult to change. And normally you don't want to change it. So also, we all know, we have some challenges on top of that. The ones I consider the biggest are your own assumptions about the legacy code, because you don't really know what's happening there. You try to understand, and you have your own idea of what is happening there. And I'm sure many other engineers had their own assumptions before. And there is a relation of cause and consequence with the lack of documentation. When you think about guidelines and patterns, it's not in place, so you start creating your own. And I think I dare saying that if there was documentation, this code wouldn't be legacy, at least for longer. And the last one is inconsistency. That is a consequence of the other two. If you create your own assumptions, you don't have documentation. Every time there is a new iteration over the legacy code, you have a different pattern. So you end up with a legacy code with MVP, MVVM, RX, coroutines, everything in the same place, and you really don't want to touch it. Things at the time were built for a reason. Like the engineer that were working on that had a context, and I'm sure that today you would be able to do it better. But are you sure you will be able to do it better at the time the engineer did, and especially not only the technical restrictions, but the product knowledge that the engineer had at the time? Because the main reason the code start getting too convoluted is because of changes requirement, and that's directly related with the product. At the end of the day, code is code, or it works or it doesn't. And when you're talking about a 7 years code with 5 million downloads and 7% of the traffic of the whole app, we can understand that it works. So we don't want to take chances when you're thinking about making it better. We don't want to create a future legacy, right? So another piece of context for this time, thinking about late 2019, early 2020, product came to us with a new idea. It would be the unified search. As you can see, UI-wise, it has some similarities, like the search controls up there that you can change tweaks and search parameters. You have the flight results there, but you can see at the bottom, you have hotels. So pretty much what we're trying to do is to deliver one more inventory to the user to create a bundled experience, everything together here. For the sake of this presentation, I'll be calling these inventories verticals, okay? So remember that because I will revisit later. So an inventory inside of the unified search that can bring different types of result sets is a vertical. So the one at the bottom is a hotel vertical, and at the top is a flight vertical. Okay, so we understand, we have the background here, and we understand what we want to achieve, not with much depth on this. So we start thinking, okay, how we can make it better. We need to start putting our stuff together. Then the first thing you have to do is recognition of the problem, because it's not only about convoluted code and spaghetti dependencies. You really need to understand what is the real problem. The more clear the problem statement, the more obvious the solution. So it's tempting to go for Shine frameworks and try something that you heard in a DroidCon, but please give 2 steps back and try to understand exactly what is the problem. Analyze the past so you can build a better solution. See through the convoluted code and think what is creating unplanned work, attrition on the component, and even not helping on retention of new talents. So doing this work with the current legacy code we have, we end up with some problems. First is the shared ownership. Before explaining the problem, I have to give you what is the concept of ownership at Skyscanner. So we have really strong idea of each product, each squad or team owns its own feature in a term of our ownership. And we also have some scripts that help us in this work. For example, we have on our mono REPL, we have a catalog YAML file that you can define what is the ownership in terms of files. You see that on directories. And you can set what is this owner, information about the Slack channel, and so on. And one of the reasons I have that is to ease the discoverability of our code. And also, for example, when you raise a PR that touches other squads' code, you can automatically ask for their review. And you cannot merge unless you have approval of every owner. So, okay, this is the ownership part of it at Skyscanner. So again, flight results. This is the screen we own the code base of it. It's a single experience, right? But this page here, price alerts, was owned by another squad. The flexible tickets was owned by another squad. And the echo itinerary owned by another squad. Everything under the same code base. So at the end of the week, we had tons of PRs to review with no much context what is happening, but we still had to give our approval to that. And you can understand that it brings a lot of friction between squads in some cases. We have problem of God models, and this is especially thinking about if you have a lot of contributions from other squads, and they need to create new view states to your feature, we didn't have really good idea between view state and domain. It was a single model. So you had to change the models if you want to change the state that is provided to the screen. And at the end of many iterations, you might have a gigantic God class that you don't really know what should be there and what shouldn't and what you can remove. So we had a class called itinerary v3. So it could keep growing. Disparity between platforms, it's not that, it's quite common in many companies, but in this case here, it's also related to domain logic. We're getting data from our server, and there's a lot of data that I have to process on the client side, and we're doing both Android and iOS, and at the end, like after 7 years, we're still finding some issues that we're doing different in both platforms, and it's quite related to the God models part. And last but not least, UI components to coupled. And we use a lot of fragments on the legacy code, but the truth is that all the fragments, we're dealing with the implementation. So when you put fragments together, they really know what was the other fragment. So it was really coupled. So for example, product had one idea before unified search. It was the first iteration of a unified search idea. There will have a cross-link at the top. There will be a tab, flights and hotels. The idea is that when you click in hotels, we inflate the hotels stuff. And when you click on flights, it's a tab. At the end of the day, after a lot of investigation in spikes, they decided not doing a tab. So it looks like a tab, but when you click, you navigate to the hotel screen and you navigate to flights because it was too hard to make it modular. So compromises, right? Okay, we understand all the problems we had, but as I said, it was a 7 years code base. So a lot has changed in the company, and not everything was in a legacy code. So to avoid creating too much disruption, we had to understand what was the current state of the code base, like how to do things better. And we ended up with two things that were happening at the company at the moment, and we wanted to bring this to our solution. First is modularization. It's not that different from many other companies, but I'll just give a brief explanation. You have a feature, and your feature normally has two Android modules. One is a contract module, and the other one is implementation module. The contract exposes data classes and interfaces, and implementation it holds core logic and dependency injection. If you have another feature owned by another squad, and you can get information from each other if the implementation depends on the contract. It's good architecture-wise because we respect interface segregation principle, and it's also good for the build time because we don't need to wait for the implementation of the other squad to be finished to be able to build our own module. So, and we try to avoid contract to contract, implementation to implementation because of possible dependency cycles and the build time I just said. The other thing is widgets. We have a fancy name for a simple thing. In fact, this is pretty much a fragment that we treat as a black box. And it just implements a contract for input, and it can handle its own side effects, or it can send information to a listener. But the thing is, we don't expose what is the fragment type. We hold it, a factory is wrapping this widget, this fragment. So what it delivers is a plain fragment. So when you are injecting a fragment on your screen, you would use a factory that will deliver a widget, but you don't really know what is the type. You just know the contracts that it's implementing. So when you have an action, the fragment can have a state change or side effects. So at the end of the day, when you connect things together, you can have many fragments on your screen. They don't know each other, but they all connected and more modular. Okay, this is what we had, and we want to use this. Okay, now it's time to create a strategy. Something to be followed is regarding the chosen framework or sub of letters you choose for a pattern. This might be revisited every new iteration, but rather than starting from scratch when you start a new discussion. It helps to create boundaries so the discussion, so it's scoped, and again, it avoids disruptive changes. This is a quote from Will Larson in his staff engineer book. He says that some of the best strategies you write may at the time feel too obvious to bother writing. As more experience you get in engineering, you see that as the simpler the better, and that's normally applied for all this stuff. Strategy is one of those. Okay, so this is the problem we have. Couple UI components, starting at this, what is the possible strategy it could have? So thinking about the widgets, we put some stuff together and end up with the idea of widgets plus host that I will explain now, and some composable views. Okay, you know what a widget is. Now, thinking about the flights day view, we have divided in 3 widgets: search controls widget, header widget, and flight result widget. All those 3 widgets are connected together within your host. When one of the widgets has a state change, some action that will change the state, and this state is meant to change the entire host, then it sends an action to the host does some business logic, and sends state changes to the widgets. But you might have actions that affect widgets, but they don't affect the whole screen. For example, a single scroll inside of the header just to trigger an animation. In this case, the header widget will solve its own state without letting the host know. So they know how to resolve themselves. And composable views, it's pretty simple idea. It's like nothing disruptive again. The idea is that every view we have, we try to compose in smaller views, but every view we create, we follow some guidelines. They have to represent a UI model, so we can map a UI model into a view. They are accessibility ready. This is a really important thing in Skyscanner. We even have some accessibility champions to help us for following these guidelines. Dark mode ready, and this is pretty much by following the design system library we have. By the way, look at Backpack. It's an open source library for one to look. And instrumented unit test. This might sound a bit controversial, but it's quite simple as well. The idea is that we have, for every view, we have a test that pretty much is testing output and input and output. We just render it. We don't need an activity, and we just asserting the properties of the view. We don't care what's being rendered on the screen. We care about the properties it has, if visible, color, size, and whatever. So we really create unit tests for each view. So when we think about instrumented tests, we can really think about integration rather than unit. So when we do integration tests, we really think about how the components connect together. Okay, the second thing we're talking about is disparity between platforms, and we see that this is related to the got data classes. The problem here, especially because we grow the domain logic too much, and it's hard to understand what is the source later. So we use a simple concept that is also widely used, and this is single source of truth. I'm not going to explain exactly because okay, I will explain. So the idea is we have a single source of truth. For example, in our case, is the BFF. And the BFF, what it does, it gets a lot of information from many inventory services, and it sends to the client a single domain, something that the client doesn't need to do a lot of work on top of that. The client can get this domain and map into UI views, but it doesn't need to be one-to-one mapping because the client can create decoration on top of that. So the UI models are like one of many. The idea here is that the domain on the client side represents immutability. This is used in this way because we might need to create filters, sorting, and other stuff in the same current state, and it doesn't really matter what is rendered on the screen, but what we receive from the backend. So at the end of the day, UI models are not trustful, but they what used to render. So they are pretty much a decorated copy that we add some stuff. And then at the end, we have the shared ownership. This was the biggest problem we have, and then it demands a bigger solution. So we're thinking, why can't you use the modularization idea and create on-demand features? So instead of putting stuff on our code base, they can create on their own module, and we can just expose it. So pretty much, this is the flight results screen. So if you were this is our contract. So what we do, we expose a view holder interface and a base plugin interface. The contributor will create a view holder using this interface and create a plugin implementing a predicate based on the interface. The predicate pretty much is a filter that will return true or false based on its own criteria. It's a lambda that we pass as a parameter the domain, and they decided if this domain should be replaced or not. I think we'll be clear in a minute. The contributor implementation will depend on the contract. And then the contributors create a contract to expose their own specialized plugin. And our implementation will depend on their contract. And also our implementation will depend on our own contract. At the end, on our side, the contributor just needs to register the plugin saying, I want to change your data, and add a view type ID. That's it. So at the end, we just have to review 2 lines of code in our code base against 300 lines had to do on the legacy part. So interface of the plugin is pretty much this. We have a predicate, as you can see, is a lambda with the context of a model that will return Boolean. So, for example, if in the model has itinerary is echo, like an echo itinerary, we can get the domain data and return true or false. And if it's false, we do nothing. But if it's true, we can replace the domain with what is provided by the view holder. So that's the idea of creating on-demand features inside of a list. Okay, so we have this strategy in place, host, single source of truth, and plugins on on-demand features. How to make sure the strategy is followed? That's quite straightforward. We need documentations and contribution guidelines, so get your stuff together with Confluence. Don't be afraid of creating diagrams and UMLs, that's really useful. I know, but it's good. And then mature team doing code reviews. Code review is the gatekeeper for strategies. If you don't like doing it, you're doing it wrong. So again, put the shit together and do a good code review. I think we have another talking about code review here. Not totally sure. Okay, so revisiting what we talked so far, we had the recognition problems, create, commit to strategy, strategy in action. So we had a way of working. We have a way of working to try to unblock as much work streams as possible. And the first thing on this is to define contracts and APIs. We had a backend to work on, so we cannot wait this to be ready, so we need to have a clear API. And also, we have the widgets that expose contracts. We don't have the implementation of widget, but we know the contracts of it. So we define all the interfaces and APIs so we can keep working. In the meantime, we're working on a plugins proof of concept because we had only the idea of it to be sure that it was possible. Then we work on UI models and domains to respect the single source of truth, and this is following the API guidelines. And then UI components and widgets, because as you can remember, unified search is quite similar in terms of UI when comparing to the flight results. So we're trying to think in all common stuff first. This is a good thing because we have a core logic for when doing searches for different types of inventories that we do a pooling search. So we do a request to create a session, and we keep pulling on it until we get all the data. But this can be used in many places. What we did was creating a really reusable pooling that you just need to implement what the actions you need to do, and you can pull in any service in returning any kind of DTO. You just need to respect our market interface. And then at the end, we finished the first pooling plugins implementation. Okay, at this point, we had a really good ground on the flight results legacy and new, like redoing what we did bad in a good way following strategy. And then product gave us the green flag to start the unified search. So at this point, we just had to put the flights widget together and create a hotels widget following exactly the same stuff. So we create our own UI composable views, create a widget, following contracts, so on and so forth. And one important thing to say here, both widgets were owned by our team. So we're not thinking about shared ownership of widgets, we're thinking about shared ownership of items in the list. And at this point, it was a good idea. At this point, it was working fine, and it had no problems. We even, that's the final, how it looks like. And we even had some contributions that I will show in another one. But first, we're talking about rollout plan. So we have the implementation finished. It's on trunk. It's ready. We don't have to do much more, right? Wrong. At Skyscanner, we have a pipeline to achieve operational excellence. Release trains, phase rollouts, configuration flags for every new feature, experimentation, custom dashboards, and alerts. So we follow SRE techniques for mobile development. SRE is software reliability engineering, and it helps to find a balance between releasing a feature and make sure it's reliable to the users. And that's all that cares for Skyscanner. Okay, this is the pipeline when you're thinking about rollout-wise. Okay. The first one, we put the feature flag together, so we can always merge the trunk without thinking about creating separate branches. So every new change is released to the trunk under a feature flag. Then we put together some business and functional events using an in-house tooling. If you want to know more about it, you can come to me after this. It's quite interesting structure. When we believe it's finished, we always pass through the release train, but it's normally under a feature flag. But at this point, we have a release train that every 2 weeks, as I said before, a phase of rollout until reaching 100%, and on top, sorry, it's map events now. So on top of the business event we created, we use an in-house tooling to map from a Kafka topic and create our own metrics based on the events we created. And these metrics are used to create dashboards and alerts. I will show you in a bit. And then at the end, we have A/B tests that are roll out the delivery of the feature flag. And after about 2 weeks, we have analysis to understand how was the product. When I talk about dashboards and alerts that we create, currently we're using Grafana, and we create many dashboards with really specific data that we can use as metrics. And when talking about alerts, it creates automatic messages on Slack based on predefined SLOs. And it all can be changed remotely, so it doesn't need a new release. You can do it all from different services. Okay, after the 2 weeks, we had this is one of the analysis we did. So you can see that we had a good improvement on app attachment rate. Pretty much is the relation between a user that books more than one vertical against the user that books a single vertical or any vertical. So we had a good improvement there. So pretty much that's what we could use as a success for the experiment. We had some minor iterations, but let's skip this here. And then talking about contributions, at this point, we had a new ads on the unified search, and we had to review about 50 lines out of 350 lines in a PR. And this is an interesting thing. A new vertical contribution, as you can see, we have a car there. It's really simple. It's static. But it's still being really simple. We had to review 80 lines out of 828. So, okay, this is a successful iteration, successful experiment. So I believe that's done, right? We're done here. No, we were in a data-driven environment, as I said. So when something is successful, that means we can do more successful stuff on top of that, and especially more complex successful stuff. So every time the product, that's important to understand, every time something works, the product wants something much more complex on top of that. So you need to be ready for this. So now what they want is to be able to create new verticals. Instead of thinking just an item, they want an entire vertical. For example, the car vertical, the inventory, they want something really complex on top of that. And that really simple one was given about 80 lines out of 800, I think. That's quite a lot. So I'm thinking how we can make it better. So first, we use this strategy as a like creating the boundaries. So thinking, we have this strategy, what's the implementation have that we can keep following this strategy. So first, you have to understand what was in terms of ownership on vertical. When we have a vertical and like another squad wants to create something, we own the details, the state handling of the widget, the navigation, the ordering, and the screen state handling, the whole screen handling. And the contributor was only handling the state rendering. Like, that's why we're having to review so much. So, okay, how we can move the DTOs. So, okay, plugins work really well for results. Why plugins cannot work for verticals? So what I think is we can ask the contributors to register for plugins for different verticals. And they would give us a vertical factory to tell how to create, a vertical parser to tell us how to parse, and the payload key. So we can, when we get the payload from the backend, we can just say, okay, it's here, that's what you need, pretty much. So doing this, we could move the response and request to the contributor. Now, widget state handling. As we don't know about the DTO that is being passed, but is still passing this to the widget, we can get this data that is opaque for us and wrap it with some session information that we know, like if it's completed, if it's still pulling, if it has failed or something. We can just wrap this and pass to them so the widget can render its own state. So now we're giving more responsibility to the contributor. And navigation. Now the vertical widget is much, much smarter. So we can also give them some responsibility as treating side effects. So we're also passing the navigation to the contributor. And at the end, start ordering. We had this because at the beginning, when we're building unified search, the host know exactly where was the flights, hotels, and where was the hotels, the flights widget, and where was the hotel widget. But now, it doesn't need to know. The host just needs to know who are the verticals that are registered, and then I will do a for each over this and just inflate on the screen automatically. Doing this, the host can choose what's the ordering and doesn't need to be static. So I decided putting this under a feature flag, then we can change remotely. So every time the host is going to inflate the screen, it checks the feature flag and sets what is the ordering. So now we have a dynamic ordering. And now we only own the dynamic ordering and the screen state handling. And the reason we need to own the screen state handling is because we have some global states like empty or failure. If every vertical fails, we need to show a single failure. If every vertical is empty, we need to show a single state. So that's why you own it. But it's much more balanced now. Okay, thinking about development plan for this second iteration. It's quite different, right? Because now we're not delivering a full new experience. We are delivering a new experience for our engineers. But we need to deliver the same experience to the users. They need to have exactly the same they had before. So the hypothesis here is just this change, there's no harm to the user. So first of all, again, we define the contract so we don't get blocked. And at this time, we had other squads already creating some verticals. So we gave them, okay, respect this contract, and we do our part. Respect this contract, create our implementation, and at the end, we'll put this together. So pretty much the idea. Common resources, because we're creating two exactly the same screens, one using plugins, one without plugins. We try to get all that was common between them and put together, but also everything that wasn't common, instead of creating if-and-elses, we decided duplicating. This can be quite contradictory, but in this case, it's quite good that duplicate code, so we can, like, with no remorse, just delete what is old as soon as we know this is good. So we don't need to keep in the same class, in the same classes, in the same logic, and also writing unit tests for two different behaviors is quite a nightmare. So having duplications and thinking about unit tests here and here for the same experience with different implementations is quite easier. And also a lot of feature flags. I had feature flags all the time for turning it off because you have many entry points. So feature flags for the win here. And again, the A/B test with a different hypothesis, there will be no harm. So at the end, after 6 months, we had some problems. We had some in production that I had to turn off, but because of the feature flags, we could just turn off, reiterate, and send it again. No harm to the final user. We have really good stories contributions now. Sorry, vertical contributions now. For example, we have stories at Skyscanner. Yeah, it has arrived. And we also have cars vertical at Skyscanner. Both we had to review about 3 lines because everything else is on the contribution side. And again, the second contribution is completely following your first each strategy. So that's really important to focus. Okay, now it's over, right? We already have a really good contribution guidelines. We had a lot of successful iterations. No, we are in a data-driven environment and they want more complex stuff. But this is a story for another talk, I believe, but we already have this happening. One colleague of us has already ran the design review. We already have proof of concepts. And the main idea here is that we want to be able to let other squads to have their own plugins. So we're kind of creating a framework on top of what we're doing internally, at least. And good thing, we're still following the same strategy. And that's really important because most of the iterations we have is because of other squads wanting to contribute. And when you have other squads, have more engineers with more ideas wanting to do different things. And if you don't have a scoped conversation, it can get mad. Like you can talk about so many things, disrupting everything, and it's not really good when you think about flexibility and keep growing. So it's important to have a strategy to keep boundaries. Okay, so finally we can talk about the key learnings, and I think we have some. First of all, analyze past problems. Don't be too rushed to going for the solution. I've seen many engineers failing this. It's really tempting to go with MVI and this kind of stuff, but it doesn't really mean if you don't have a strategy. You can go with any implementation one as soon as you have clear guidelines and problems in place. If you understand the problem, you will definitely get a good solution. Understand company behavior. As I said, one thing that is really clear at Skyscanner, we always want to try more complex stuff. We always want to try more. So it's really important that you understand the past so you can analyze also the behavior of the company, how it works, because it will affect directly the requirement changes on your code. Focus on strategy rather than implementation. I talked this before. So again, strategy is meant to be really long-term stuff. Implementation, as we see here, can change many times. But it doesn't mean you need to fit any solution into your strategy and make compromises. When you reach to the point that you need to do too much tweaks to fit the strategy, it might mean you need to change your strategy. Create awareness as documentation and guidelines. I know most engineers don't like doing it, but you have to. It's a really good point. When you join companies with really good documentation and you can really understand why it was built that way, you can do better things, and you will be avoiding the inconsistency and the problems you have with legacy code. So this, I believe, is the key code, the key thing to keep your code away from legacy. I know it's sometimes boring, but good PR is the gatekeeper. I'm not going to be too annoying on this, but do good PR. Try to have a culture of no shame and no blame. It's really important. It can be really toxic, not only for the team, but also for the code. We all need to understand that the PR is there to make sure that we have a good code so we can work better in a longer term. Be close to the product team. That's really important. The PO and PM, he's not your enemy. He's there definitely to help you. And if you can use him or her correctly, you got a really good grasp of the future. We understand you can use your own and your skills to analyze the past, to understand behavior, but you need them to understand the future. And the future is really important for requirement changes, so be aware of it. And last but not least, again, follow SRE techniques. I know if your company doesn't follow it, please take a look. There's a lot of documents on Google. This is really useful for backend stuff and web stuff, but I would say because of release cycles, problems we have, not problems, but challenges we have in the mobile development, this is even more important for mobile engineers, and so we can make sure that we keep a really healthy state code, and we can understand we're delivering the best for the users. So that's pretty much all the learnings I have shared with you guys, so thanks for being here.